Hello, this is Dr. Armand bringing you another lecture in general chemistry. In this lecture, we'll be discussing about the mole, Avogadro's number, and converting between entities, moles, and mass. So sit back and relax and enjoy the show. So when we begin in stoichiometry, we have to begin by discussing the mole because the mole is the important component in stoichiometry. So for stoichiometry, we're converting between moles of reactant, for example, to moles of product. And the mole helps us link mass to number of atoms, etc. And so what was determined is that if you have 26.98 grams of aluminum or 137.3 grams of barium, they both contain the same number of atoms. The ratio of the sample masses equal the ratio of the atomic masses. And so therefore, since they contain the same number of atoms, the number of atoms present in this sample is referred to as a mole. So whether you have 26.98 grams of aluminum or 137.3 grams of barium, they contain the same number of atoms, which this same number we define as a mole. And a mole is equal to the number of carbon atoms in 12.01 grams. So 1 mole equals 6.022 times 10 to the 23 carbon atoms. This should be. So 1 mole of anything contains this many entities, whether it's a mole of atoms or a mole of molecules. If you have a mole of something, you have 6.022 times 10 to the 23rd of that something. And this is commonly, when we look at atoms, molecules, and formula units, this is commonly referred to as Avogadro's number, N sub A, which is the number of entities or units of a substance per mole. So sometimes instead of units of a substance, they use entities. So whatever entity you're dealing with, if you want 1 mole of that, you need 6.022 times 10 to the 23rd entities. So for example, if you have 1 mole of electrons, you have 6.022 times 10 to the 23rd electrons. 1 mole of eggs, you have 6.022 times 10 to the 23rd eggs. 1 mole of atoms, 6.022 times 10 to the 23rd atoms. So as you can imagine, 1 mole of anything is this many of that entity. And so with these atoms, with these elements, we get what's called a molar mass. And the molar mass is the mass of 1 mole of substance, and this is used both for ionic and molecular compounds. So if you know the formula of the compound, you can calculate the molar mass of that compound. And so there are some different names, alternate names that we use sometimes for molar mass. Sometimes we say formula weight, which is the molar mass of an ionic compound, or molecular weight, which is the molar mass for molecular compounds. So you can use, say, molar mass of a compound, or you can say the molecular weight, etc. So how do we calculate molar mass? Well, you look at your formula and you multiply the molar mass of each element by the number of that element. So here we have 1 carbon and 4 hydrogens. So the molar mass of the compound is you take 1 times the molar mass of carbon, which is 12.01, and add it to 4 times the molar mass of hydrogen, which is 1.008. And 16.04 is the molar mass of that compound. We look at NH3. We see we have 1 nitrogen. The molar mass is 14.01. And again, this mass here comes from the periodic table. It's usually the number below the element symbol. So that's where that 14.01 comes from, the 12.01, the 1.008. These come from the periodic table. Then we have 3 hydrogen times the molar mass of hydrogen. We get 17.03 grams per mole. So if you have 1 mole of methane, it weighs 16.04 grams. If you have 2 moles of methane, it weighs 32.08 grams. So we'll look at one more example. Let's say we have SF4. So we have the molar mass of this would equal 1 times the molar mass of sulfur plus 4 times the molar mass of fluorine. And we get 108 grams per mole. And that's how we calculate molar mass. And this is very important to calculate it correctly, because everything we do in chapter 3 and beyond, you'll need molar mass as well. So now going between mass, entities, and moles, which moles is amount. So we want to go between amount of something, the mass of something, and the number of entities. So when we're converting between amount and mass, so amount and mass, and again, amount is moles. That's amount. So when we're converting between moles and mass, we use mass divided by molar mass gives us moles. And sometimes people use a little pictogram to denote this. So we have mass, molar mass, and moles. So mass divided by molar mass gives us moles. Moles times molar mass gives us mass. So if you want to convert between mass and moles, you use this equation. If you want to convert between moles and entities, we use the next equation. So entities can be anything. It can be atoms, molecules, formula units. So just to let you know, for covalent compounds, they're made up of molecules. Ionic compounds are made up of formula units. And so here again we use Avogadro's number times moles gives us a number of entities. And we can use another triangle that people like to use. Involves this. So we have number of entities so number of entities on top, we have moles on the bottom, and Avogadro's number on the bottom. So if you want to find moles, you take entities divided by Avogadro's number. If you want to find entities, it's moles times Avogadro's number. So mole is the middleman between mass and entities. So you have to go through moles. So if you're given mass of an element, or mass of a covalent compound, or mass of ionic compound, you would use the molar mass to convert it to the moles of that element, or moles of covalent compound, moles of ionic compound, etc. Then you would use Avogadro's number to convert it to number of atoms, molecules of elements or compound. This is a little bit. So once you convert it from mass to moles, you use Avogadro's number to convert it to entities. Typically the entities are atoms or molecules or formula units. So if you're dealing with elements, it's atoms. If you're dealing with covalent compounds, it's molecules. If you're dealing with ionic compounds, it's called formula units. So this is a process we're going to go back and forth to convert between mass and entities, entities, and mass. So now if you want to know the number of moles in an element, we can get that from the chemical formula. Or if we want to know the number of entities, for example, we found the number of entities, we want to find now the number of, from that we can find the number of ions or atoms. So once we find, and again there's many different ways to do this, but if we're given mass of something, we can find the moles of that compound, and then we can find the molecules or formula units of that compound. And once we find the molecules or formula units of that compound, we can find the ions or atoms of that compound as well. And we do this from the chemical formula to go from molecules, formula units, to ions or atoms. Alrighty. So now what you can do is, if you want to find the moles of a particular element in the compound, you can use the chemical formula for that as well. So there's 2 or 3 different ways you can go about solving these different problems. So what we're going to do is, we're given mass, we can convert it to moles, convert it to entities, then convert it to ions or atoms using the chemical formula of that compound. So now we have a few examples. We want to calculate the following. So the first one is the number of molecules in 182 grams of C4H10. We'll define molecules equals moles, which is N times Avogadro's number. So if we know the moles and we know Avogadro's number, we can solve for N. Now we know Avogadro's number. (6.022 e to the 23rd molecules per mole). Now in order to calculate molecules, we need the moles and Avogadro's number. But you see here we have mass. So we need to go from moles, mass, to moles. So moles equals mass divided by molar mass. And so we know the mass is 182 grams. The molar mass is equal to 4 times 12 plus 1 times 10. This equals 58 grams per mole. So we know the molar mass and we know the mass. We can calculate the moles. Moles equals 182 divided by 58. 3.14 moles. So now we found the moles, we can find the molecules. Make sure you use orders of operation, use parentheses. And it's going to be a really large number. We get 1.89 e to the 24th molecules. So that's how many molecules of C4H10 are in 182 grams of C4H10. Next, we want to know what's the mass of 4.57 times 10 to the 25th formula units of calcium phosphate. So to find mass, we need to know the moles times the molar mass. So if we know the molar mass in the moles, we can find mass. So molar mass equals the number of calcium times the molar mass of calcium. And again, I get these from the periodic table. Plus, now here, the 2 gets distributed to the phosphorus and the oxygen. So this becomes 2 phosphorus times 31 plus 8 oxygen times 16. That 4 times 2, we have a total of 8 oxygen. So now we have a molar mass of 310.3 grams per mole. Now we know the molar mass, we can find moles, and then if we want to find the moles, so moles is our question mark. So we found the molar mass, we need to find the moles. So now we have, since we have formula units, moles equals formula units divided by N A, Avogadro's number. So we know the formula units, we know Avogadro's number, we can calculate moles. Make sure you use parentheses for order of operations. And we get 7.589, or we should just say 75.89 moles. Let me double check. So that's the number of moles. Now we know the moles, we can find the mass. So mass equals moles times the molar mass, 310.3. And we get 23,550 grams. So that's the mass of 4.57 times 10 to the 27 formula units. Now, in the last example, we want to know how many ions of bicarbonate are contained in 75.7 grams of iron 3 bicarbonate. So we want to know the number of ions we know that's equal to the number of formula units times 3. Because for every one formula unit of iron 3 bicarbonate, there are 3 ions of bicarbonate. So in order to solve for the number of ions of bicarbonate, we need to determine the number of formula units. So that's our question mark. And so the way we find formula units is equal to the moles times Avogadro's number. So Avogadro's number we know, but we need to find the moles. So moles is our question mark. So using the other equation, we know that moles equals mass divided by molar mass. So we know the mass of iron 3 bicarbonate is 75.7 grams. The molar mass we can find out. So 1 iron times 55.85. Now again, this 3 gets distributed to the hydrogen, to the carbon, and to the oxygen. So that becomes plus 3 times 1 plus 3 times 12 plus 9 times 16. And so the molar mass is 238.85 grams per mole. Let me double check. So now we know the molar mass, we know the mass, we can find the moles. So moles equals mass divided by molar mass. So now we know the moles, we can find the formula units. So number of formula units equals 0.317 times 6.022 e to the 23rd, which equals 1.91 e to the 23rd formula units. So that's the number of formula units. Now to find the number of ions of bicarbonate, would be 3 times the number of formula units. 5.73 e to the 23rd ions. So that's how many ions are in 75.7 grams of iron 3 bicarbonate. So what we did is we found the molar mass. From the molar mass and the mass, we can find moles. From the moles and Avogadro's number, we can find formula units. From formula units, we can find number of ions. And so there's 5.73, 10 to the 23rd ions of bicarbonate in this sample of iron 3 bicarbonate. Let me double check my work. All right. And one last example here, we have the structural formula of allyl sulfide, which gives garlic its characteristic odor. Calculate the number of carbon atoms in 58.5 grams of allyl sulfide. So again, we notice here, if we count the number of carbon atoms, each black sphere represents a carbon atom. So we have 6 carbon atoms. So we know that the number of carbon atoms is equal to 6 times the number of molecules. Number of molecules is equal to the moles in times Avogadro's number. And the moles we know is equal to the mass divided by the molar mass. So we know the mass is 58.85 or 58.5 grams. The molar mass, we have 1 sulfur plus 6 carbon times this molar mass of 12. Again, you get these at the periodic table. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen. And so this would be 114 grams per mole. So now we know the molar mass, we know the mass. We can find moles now. We get 0.513 moles. Now we know the moles, we can calculate the molecules. Remember to use parentheses. Three 0.09 e to the 23rd, and this is molecules. And lastly, we can find number of carbon atoms equals 6 times 3.09 e to the 23rd. One 1.85 e to the 23rd carbon atoms. So that's how many carbon atoms are in 58.5 grams of allyl sulfide. Again, what we were looking for was carbon atoms, which is equal to the number of molecules times 6. The reason it's 6 is because there's 6 molecules, excuse me, there's 6 carbon atoms in one molecule. So next we need to find the number of molecules, which is equal to the moles times Avogadro's number. Moles is equal to mass over molar mass. So we knew the mass, we calculated the molar mass. We could find moles, then we found molecules, and then we found number of carbon atoms. Let me double check my work. And that is correct. So that's all for this lecture on Avogadro's number and calculations involving Avogadro's number. Again, for most exams, the Avogadro's number is given to you. You just need to know how to utilize it. And that's all for this lecture. Until next time, Dr. Armand signing off.